Assalamualaikum warahmatullahi wabarakatuh to Mr. Razali. So now I will introduce my group member for subject electronic principle assignment, and my group get set question 9, which is operational amplifier OM. So uh, so this is me. My name is Muhammad Adib bin Azmi. Number matric P0820100344. So next, this is my group member. Name Amirul Nuqman bin Khalid. Number matric P0820100427. And next, so her name is Paventhan anak lelaki Kumarasamy. Nombor matrik B0820100098. Next, lastly, Ahmad Irfan bin Anas. Nombor matrik B08201036.
Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, sir. My name is Amirul bin Khalid, and my matrix number is B0820100427. And today I'm going to show you how I simulate my assignment works for subject Electronic Principles BEEI1453. And my groups get the question 9 set, which is amplifier, operational amplifier of M. So the first question is figure 1 shows non-inverting amplifier circuit, which is consists of 12 kilo ohms for R1 and RF is 360 kilo ohms, and it is connected into the negative terminal. So this is the V1 and this is the V out. So the first question is determine V out if V1 equals to negative 0.3 volt. So this is how I simulate. So first I connect the power supply to negative 0.3, and the rest is just like the circuit in the figure, and then I connect the multimeter at the output to get the result. So so the result is negative 9.231 volt for the first question. Next we will take a look at the second question, which is determine the V1 if the output voltage V out equals to 2.4 volt. So I got the second circuit here, which is almost the same, just the power supply I bring it to the V out. So V out I set it to 2.4 volt, and the rest is just same as the circuit given in the figure, 12 kilo ohms for R1 and RF is 360 kilo ohms. So let's run and we'll take a look at the multimeter, and the value of V1 if the V out is 2.4 volt is 57.984 millivolt. So that's all for my for the first question. I'll pass the next question to my other team members. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adib bin Azmi, and number matric B0820100344. So next, I do question 2. Question 2 is based on electric circuit shown in figure 2. Determine whether the LED 1 and LED 2 is on or off for V1 equal to volt and V1 equal to 3.5 volt for both LEDs silicon LED. So this is the circuit. So for V1 we use 2 source, 2 volt and 3.5 volt. So for V2 we use 4 volt, and then R1 I use 100 kilo ohm, R2 with 500 kilo ohm, and this is OM, and LED 1 and LED 2. So we simulate in multisim. So this is the circuit. So first, for V1 I use 2 volt. So let run it. So the result, LED 1 is off and LED 2 is on. So I change uh, V1 to 3.5 volt. So run it. So the result we get LED 1 off and LED 2 off. So that's it. Thank you.
Hello sir, I'm Paventhan here. So moving on to the third question. Where uh, the question is about the multiple stages operational amplifier, where the circuit consists of three minimal operational amplifier circuit respectively. So the first question of question 3, it asked us to name the types of amplifier in the multiple stages of an operational amplifier circuit. So circuit A, well, this circuit is a non-inverting circuit since the input is applied to the non-inverting input or terminal, while the inverting is grounded. So this is a non-inverting circuit or operational amplifier circuit. So the circuit B, it will be inverting operational amplifier since the non-inverting input is grounded, while the the inverting input is connected to the input. The third circuit, it will be inverting summing amplifier since it has more than one input. So we call that as inverting summing amplifier. The second question, it asks us to calculate the output voltage of amplifier. So output value at each of the circuits. So to find out the answer, we have to rebuild this circuit in multisim software. So after rebuilding it in this multisim software with applying DC voltage at each input, and to find out the voltage output value, we have to connect multimeter at each of the outputs that we wanted to find. So at we output of circuit B, we have to place multimeter at the output here. For circuit A, the multimeter at here, and circuit C, the multimeter at here, and find out and run the software, and we'll get the voltage output values. So that's all from us. Thank you.
Alright, thank you Paventhan. My name is Ahmad Irfan bin Anas. My matrix number is B0820103666. I will proceed to the discussion. So for question 1 is about the non-inverting amplifier circuit. The input voltage signal Vin is applied directly to the non-inverting positive input terminal, which means the output gain of the amplifier become positive in value. This is because the result of output that Amirul do in question 1 is in phase with the input signal. So for question 2, when the 2 volt applied at the V1, the operation will be inverting amplifier. This is because the input voltage for V2 at negative terminal is higher than V1. This cause the LED 2 is on because the terminal is backward compared to LED 1. But when the 3.5 volt is applied at the V1, nothing happened because the value of both input terminal is almost the same. So for question 3, the circuit A is using a non-inverting amplifier. Circuit B and circuit C are using inverting amplifier. As we can see, the result for circuit A is a positive value for the Vout. In this configuration, the input voltage signal Vin is applied directly to the non-inverting positive input terminal, which means that the output gain of the amplifier becomes positive in value. While circuit B, the input voltage signal is applied directly to the inverting terminal, which the output gain become negative in value. While for the circuit C, although it has input voltage at both terminal, the value at the inverting is higher, which the value at the negative terminal.
That means it become an inverting amplifiers and the value is negative. That's all from us. Thank you.